Hi, Tim Ard here. If your chainsaw or other two-cycle engine isn't adjusting out and running correctly, it's always helped me to understand how something works. If I understand how it works, how it's designed, I can be able to troubleshoot it and find the issue a lot faster. So I hope you enjoy this video on carburetors.
I want to go down through just some basic parts of the two-cycle carburetor. That could be on your chainsaw or your trimmer, and just kind of go through the different aspects. Here would be where your fuel filter would be down into the tank, and then you would take and think about the fuel goes in to this inlet here and then goes into the pump side of the carburetor. Here is your T or LA screw adjustment that more or less opens up your throttle and works your throttle valve in the ventura of the carburetor. Here you have high speed screw and low speed screw. Some of them are different diameters. These two are the same diameter on this particular setup. The high speed is always the one closest to the air filter. The low is usually closest to your carburetor mount. High speed screw would be farthest away from the cylinder and low speed closest to the cylinder. Those two screws regulate the amount of fuel that's going from the metering side to the actual ventura of the carburetor and the high-speed nozzle. So if we look at what that valve does, this is your high-speed nozzle in here. So there's a pushed in or a pressed in nozzle that allows for the high speed, that's wide open throttle. And then you have two small orifices right at the butterfly, and those two are your low speed idle and then an intermediate hole for acceleration. And then your high speed nozzle takes over. These two settings, and I'll pull out one of them, they're both the same, have a very fine tip, and they're threaded, and that goes into the metering side of the carburetor. Setting on these, basic setting would be all the way in till it seats just when it touches the base. There's a shoulder on the screw, and it would come back out 1 to 1.5 turns according to the specifications for that particular engine. This side is the metering side. This side is the pump side. And one thing that a lot of people overlook is the actual pulse feed for the carburetor. That's what makes the carburetor work. And this hole here is either attached with another orifice coming in from the side, or either it's going through the gasket and the mounting of the carburetor to the crankcase, to either the cylinder base, or there's a tube coming out below the cylinder base up to this hole here. And like I say, it could have a nipple on this side that you would feed, but this one goes through the base of the carburetor. That, as the piston goes up and down, creates a negative positive pressure in the crankcase, and that's what pulses the air back and forth to work your pump side diaphragm. The fuel then goes to this strainer, and that's really your first strainer after you would have your fuel line and your actual fuel filter in the tank. So you can see there's holes coming here and here, and in this case this would be pulsing, and it would pull up, so fuel would come in here and up into this area and down. Okay, and then that has an orifice going to this strainer And then this side over here, fuel can come up, and it actually has a valve there that works off of that pulse that we talked about. So that gasket runs the pulse, and then that pulls the fuel in. So fuel comes in here, pulse happens. This is your pulse hole. So it then creates a pull here with the diaphragm into that cavity under here, and that pulls the fuel up, or the pulse up, and then pulls the fuel, and then the fuel is pushed out on this side, goes into that orifice, up and down, and into the strainer. That gasket has to be pliable, and it has to seal properly for timing to be right with that pulse. This side is the metering side of the carburetor. This allows in a metered amount of fuel to go to those adjusting screws. Now, there is an air vent here that sometimes has another nipple, but this air vent is atmospheric pressure. So that goes to where your flywheel doesn't blow air and it doesn't go upside down, so dirt and debris gets into that position as your carburetor is mounted. This diaphragm, you've got the gasket on the metering side, and this little bump here, as it goes in and out with that pulse, works this lever, which opens your inlet needle and allows the fuel to come from the screen down a channel, and then the inlet needle seals. Now, this has a spring activation, so you have to be kind of careful here. But this spring goes under the pin in the arm. This arm is adjustable. And then your inlet needle has a rubber neoprene, or actually it's a fuel-proof type of rubber, and it has an anti-seize compound on it that seals down in that orifice. Hopefully you can see that. But that's down into this position is where that inlet needle goes, and that seals against a seat, so that only allows, each time that lever goes up and down, opens just a little bit on the valve and allows fuel into the metering side. Now, this is a pressed in high-speed nozzle that I spoke about earlier, and then this is your low-speed and intermediate holes. And so the fuel comes past here, and then this one is actually an independent system. So you have fuel comes in here and goes to the high speed, and that's metered with your H screw, your high-speed screw. Under this plug, Welch plug, is your low-speed needle, and it pulls fuel from here and then goes up into those two openings in the Ventura for the low-speed setting for idle and intermediate. And that fuel coming in that hole is metered by the L screw. So going back together, pull sets against that. This hooks into here, and that's how it lifts it. So here you can take, stand that little spring up. This goes down into the hole, and then the shaft goes underneath the pin screw that pins it down. And you have to be very, very cautious and steady fingered, as that little spring will take off. This you can see then moves that valve up and down and opens and closes it. This should be on this particular carburetor level with this recessed area, and that pin on the diaphragm then takes and moves that. This screw must be tight. You can replace the Welch plugs. You can pop that out and be able to clean those orifices going over. Sometimes they stop up. High-speed nozzles do wear out, but most of the time in that case, probably the carburetor body is starting to get worn too. But that can be pressed out, pulled out, and they usually seal with some type of a fuel-resistant sealer, or back days ago, something like fingernail polish would hold those as sealed. Diaphragm then goes on with the gasket first, and then, like I said, the cover goes in a position so that as it's mounted, it doesn't gain air from the flywheel. So if your air box is open here, you want to turn that so that it doesn't have pressurized air coming to that area, and doesn't go in a position that it would pick up dirt and fill that air hole, that vent hole in the cover. Because if it gets stopped up, the pressure is working on one side of the carb, but it can't lift the diaphragm, so you don't have the metering side working correctly. That goes down then and seals. And so there's several pressure tests that you can do to make sure that everything is sealing and working properly. Now on this side, the diaphragm goes completely against the body, directly against the body, and then the gasket seals the cap here. Usually only one screw on the pump side, usually a larger screw. So a couple different pressure tests that you can do, and this one is a little larger. You can be able to apply pressure here, and it should hold, I think it's about 4 psi on that inlet lever, and then it should unseat, and then you can close these two screws off to see if there's any leaking past the adjusting screws to the high-speed jet and the low-speed settings. And you can also then take and pressurize the crankcase to check to make sure that it's sealing and the pulse line is clear. Very important that pulse line be completely clear, however it's configured. Some have a feeding it, and some are direct to the crankcase or the base of the cylinder. So that's basics of the carburetor. Very easy once you understand it. Biggest culprit is dirt and eventually shaft wear in this area here. A lot of times vibration will loosen the butterflies, and another thing that happens sometimes, they will rotate, and when they rotate, it loses its efficiency for idle. You can see a small cutout in here, and that just goes right over those low speeds and intermediate speed holes, and that's what allows it to work.